Hi guys. Okay, so today we're looking at a Lafayette model KT208 signal generator and signal tracer. As a signal generator, it reports to put out signals from 250 kilohertz up to 120 megahertz, and it does it in 5 bands. You've got an RF attenuator, completely variable, 0 to 100%. You can go unmodulated, or you can put in a modulated tone. And you can, on your audio frequency tracer here, you have an attenuator to adjust the volume. We'll demonstrate that in a little while. And then you've got a preamp output for any small signals that you amplify up within this thing. The preamplifier will provide it, and you can do something else with it. This is a real economy model. This would have been something that an experimenter like myself, when I was a young man, would have built and used on my bench to try and calibrate my radios. Certainly not an expensive, elaborate, stable unit. It does put out a signal. It does a pretty decent job of tracking to the dial, and we'll test that right now. Right now, the output of it is going to this PM6676 frequency counter. And as you can see, we're showing 245 kilohertz on the dial right now. And we're 250 on this on the Lafayette model KT208. As I raise up, let's go to 300. And we see we got 299. Let's go to 400. We got 404. 500 on the dial. 511. 600. 615. 700. 721. 800. We're at 834, and then finally 850. We got about 893, but a small change in that. Yeah, about 893. Okay. Let's go to band B. Start over again. All right, here we are at 850. We're showing 853. Let's go to 1100. We got 1122. 1400, 1437, 2000, about 2050. Let's go to 3000, 3088. So we're at 3 megahertz now. Go to C band. We'll take her all the way back down again. Okay, C-band covers 3 megahertz to 11 megahertz. So we're on 3 right now. That's 2.94 on the Philips counter. Let's go to 4. 3.98. Let's go to 6. 6.03. Let's go to 8. 8.08. Go to 11. 11.098. All right, take ourselves back down to the D here. Now we're on D band, 11 to 45 megacycles. And let's see. At this point, I'm jumping all over the place. Should be showing 11 and we're running, I don't know, 9, 10, 12. Not doing too good on that one. Let's try 15. 13, 15. Hopping around a bit there too. Try 30. 30.46. Well, that looks pretty good. Let's go back again and see where we fall off. Here we are at 25. I'm getting 25.9. Let's go back to 20. Getting 20.4, so that worked. Let's try 15. Nope. So somewhere on this portion of the dial we're losing it. That's on the D band. Let's complete our band. We'll go up to 11. Or no, I'm sorry, this would be 45. 45 right there. We're showing 46.8. Now we go to the E band. Now E is produced by harmonics off of the D, I believe. You're not going to be able to read that directly on the counter. We're going to wind up reading D over again if I try. So what we're going to do is we're going to take a look at it using this spectrum analyzer to see what we get. Okay. Okay, we're on band E, and we're dialed into 120 megahertz. And what I'm seeing is at 123.4. I've got a peak here of harmonic. So let's try 35. I'm sorry, that would be 90, it would be 100, 110, about 105, 106, somewhere in there on this dial. And let's see if we can find it. There it is. Running about 107.8. All right, let's try 90. A little bit of trash on the bottom. I'd say that's it right there. And we've got 89.4. Let's try, see if we can get 60. Not sure what's going on there. Looks like the lower, oops, what do we get? We get something that's not, it's just another harmonic. Let's try 70. No. $80. we got a signal at 80, 80.2. So we're good there. But when we went to 70, it seemed like we lost it. All right, there's 76.8. There's 75. $73. Oh, there we are at 70. All right, let's try and go lower. Let's try and do 65. There's 66 it shows up. All right, let's go to 60. I appear to have lost it. Okay, so from about halfway the right half of the generator and this span, this is span E, seems to not be working right. I don't know why. We're looking at 50 here, and I don't think we're going to get anything, but we'll try it. There's a little blip at 50 there. Right at 52, but it's tiny. I don't think I can really... Nothing I can do about it either. And we'll do 40 just to see. Actually got a blip at 39.9, so there is something there, but I'd consider that pretty much unusable. So anyway, from 70 to 120 we've got signal. That's on band E. Band D, it looked like we were getting signal, and let's just check it here. We're on D right now. This should be 12 megahertz. Let's see if we got something at 12. Well, we got a signal at 9. Yeah, I'd say we get more like 9. And if I vary the dial, it doesn't change, so that's a harmonic from somewhere else on this unit. Take a look at 15. Well, we got a blip at 18.7, 18.9. Does it vary? It does not, so it's from somewhere else. Let us go back up to 80. Got a hell of a signal at 55. I said 80, I read wrong. We are on the D band, and that would be 25, 627 megahertz, but we're reading 55, and it is shifting, so it's going with the dial. This should be 30. Well, we got a big peak at 30, so we're working great at 30 megacycles. We've got a signal at 25 that's great. If I try to get down to 20, I don't think you get anything. Nope. There's a little blip at 18.9, so again, right half of the dial on band D is pretty much dead. The higher side of the band is working great. So it's kind of an odd situation because we're losing some of the lower frequencies on both those bands. We still have the upper frequencies, but A, B, and C, and the last half of D and E work fine. Let's take a look at the audio signal tracer. Okay, we've connected up to the audio frequency input, and we're bringing an audio signal from that yellow front Ray Caldana sweep generator up there. And we have a built-in speaker. It's actually somewhere right up here in the top. So we should be able to hear a tone. Let's turn this thing up. Okay. And let's vary the signal. Let's put this thing on sweep. Sort of sounds like something off the bridge of the Enterprise on Star Trek. So there we go. So the unit has the original build instructions with it, plus you've got some leads here, test probe, and gator clips that fit the output of the unit. Here's the kit instruction manual with the circuit diagrams. And then there's some supplementary diagrams that I included in here as well. Even, yes, it's not a precision bench piece of lab equipment. And it's certainly not going to be sold at that price. But there are parts within this. I mean, we've got 1, 2, 3, 4 tubes, as I read this diagram. Looks like 4 tubes inside of it. Audio choke, a power transformer. We've got RF coils, speaker, some test leads. So there's a variety of parts, including the cabinet, which could be reused for something. So even if somebody bought it for the parts, I think there's enough parts in here that you're probably going to wind up more than compensating yourself for whatever you spend on purchase plus shipping. So good luck, and we'll see you next time.